All right. Hello, everyone. My name is Mike Ranieri. I'm one of the co-chairs of the Redfish Forum, and I'm from Dell Technologies. Uh, I'll be here presenting with the other co-chair, Bill, about the 2025.4 release. Bill?
And I'm Bill Scherer. I'm with Hewlett Packard Enterprise, and I'm the other co-chair.
All right. Thank you, Bill. So we'll jump right into the 2025.4 release that became public a couple weeks ago in January. So off, we had an errata release with a specification, nothing really groundbreaking. We clarified that all regular expressions used in Redfish follow ECMA 262. We also made a minor clarification that in certain types of post operations, when you're creating a new resource, typically null is prohibited and is considered not a valid value you can apply to a parameter, but there are some situational cases where null is allowed based on the schema definition, and so we made that clarification to the spec that those corner cases can allow for null. We did release a new version of the Redfish message registry bundle. Um, so if you were to look at DSP 8011, it contains all of our release materials so far for the message registries. Some of the highlights include, though, we added a new registry called Manager Event, and it's to allow you to send events about what is going on with your BMC. Like, did someone do a manager reset and you need to log that or send an event about that? In environmental, we added new messages specific for cooling unit redundancy, and we also added missing fan warning messages. So those have been so we filled in those gaps there. Similarly, in power, there are also new messages for power distribution redundancy events. So if you have groups of PDUs that are operating in redundant pairs, you can convey your redundancy health as events. We also introduced a new version of the Redfish interoperability profile specification, and it adds in a new term called ProfileType. So this begins to broaden the usage of profiles, where you can now start to describe specific product implementations, and this may be useful for internal QA groups to ensure that when your development teams have built a new service doesn't meet the product requirements for that particular vendor. We've also, as usual, released a new version of the schema bundle. DSP 8010 contains all the relevant material in there. The highlights include adding a new NVMe personality management to both drive and storage resources. We've added a new port aggregation concept to network adapter and port. Uh, and while this next piece isn't new, or rather, it's not necessarily new functionality, but we did have to make an errata clarification to redundancy. There's been a bit of confusion about a couple of the properties that are worth highlighting. We've also started adding UALink support to some of our schemas. So port, processor, and protocol are now all beginning to starting to surface UALink information. So that's reflective of our new partnership with the UALink consortium. Moving into specifically the NVMe personality supports. NVMe, a couple of years ago at this point, I believe, that they created a new feature called a configurable device personality. And within that, there's a mechanism to change personality settings on your NVMe drives. You can lock those settings down. You can unfreeze them to change them later. And you can revert all these settings back to their factory defaults. And so we added new properties in drive and storage to support this capability. There's a new active personalities property added within the NVMe object for these resources. And we've also added a few new actions: set personality key, freeze personality, get personality nonce, unfreeze personality, and revert personalities to defaults. And so if you were to look at the drive resource or the storage resource and inspect personality settings, the main thing to start from is the active personalities property. So it shows you all the personalities supported by the NVMe subsystem. It shows the contents of their configuration. And as a client, you would use patch operations on this property to request changes to the personality settings. And the new actions added are used to control like the life cycle management of those personalities. So whether or not you need to lock those down, unfreeze them for future changes, or revert them because you're decommissioning a drive. As a mock-up, when you're looking at this structure, so again, within the NVMe object, you have active personalities, and it's an array of personality objects that contains the identifier, whether or not still it's in its default state, if it's frozen, if there are pending changes, what types of resets are required for the new personalities settings to take effect. Does it affect user data? And capabilities for unfreezing the personality. And then there's also a data property to show the underlying data that's associated with that personality. And unfortunately it's a raw hex string simply because there's lots of different structures that can feed into that, and to tie the Redfish standard to all the NVMe structures becomes a bit problematic. So once you're done setting up your personalities and you're ready to freeze them to make sure no one changes them again, uh, there are two methods that you can go about freezing them. First, you could set a personality key, and this is a host provided key down into the device. So if you don't want to know about the physical identifier of the drive, you can programmatically unfreeze these personalities later. This is an optional step. You could unfreeze with a physical identifier, which will be shown later. So if you want to set up your own key, you'd use the set personality key action. You specify the algorithm for producing the HMAC, and then you provide the raw key to go into it. And then once you set up your host program key, you can freeze your personalities. You can either freeze them one at a time, but with a personality parameter, or you could use 255 as the indicator to freeze all personalities, and that's a reserved value in the NVMe spec for doing this group action. Now, when you're later, if you need to make changes or otherwise decommission a drive, you would have to unfreeze the personalities. If you are going to unfreeze using your host programmed key, you need to first request a nonce from the drive. So you use the get personality nonce action, and the response would contain the nonce that you use with a key that you generate from the original host program key. And then to unfreeze the drive, unfreeze the personality, you'll issue the unfreeze personality action, specify which personality you want to unfreeze. You'd specify which type of method. There's two values today. There's host program key, and then there's also physical identifier. If it's a host program key, then you need to pass in the calculated HMAC of the key using the nonce that was originally provided. Otherwise, if you use the physical identifier, the nonce is not needed. You just pass in the physical identifier as the key to unfreeze the drive. All right, and now I'll pass it over to Bill to talk about port aggregation.
Okay, so you may recall that in the 2025.3 release, we added port splitting capability, which breaks up a physical port into multiple logical subports. Well, port aggregation is similar but reverse. So it's the process by which you take multiple physical ports, combine them together into a single logical port that has all of the bandwidth across all of the ports into a single logical unit. So to support this, we added a new port aggregation property in network adapter, and new is aggregation and associated physical ports properties to port. So is aggregation tells you Boolean whether or not something is a aggregated port. And then if it is, then the associated physical ports are links to the actual ports that comprise collectively the logical port. And so, as I said, this allows a user to group the physical ports together on a network adapter to create logical ports. And once they are aggregated, we create a logical instance of the port resource that shows the aggregated port and its associated metrics. So the logical port representation follows the same representation as a physical port. So here we have an example, a network adapter shown here as being in slot 4 with 4 physical ports. And the port aggregation object that we created inside it shows, first of all, total physical ports for the total number of physical ports. The next property, allowable physical ports per aggregation, shows an array of the sizes of aggregation that the adapter is capable of supporting. In this case, the adapter can support either pairwise port aggregation or combining all 4 ports into a single logical port, which is what we're showing in this example. Configured physical ports per aggregation is how many ports are being merged together in the current example. So in this case, we're showing that the configured physical ports is 4 because all 4 ports are being collected together into a single logical port. Configured aggregated ports is the number of ports that are aggregated together. In this case, 1. Aggregation enabled indicates whether aggregation is turned on or not. And so in the diagram below, we show that we've got the 4 physical ports labeled 1, 2, 3, and 4. And then we've got the logical port, which is labeled AGP1. And then because it's an aggregated port, a single network device function, network NDF1 shown on the right, is linking to it, and that device function is applied to all of the aggregation. Excellent. So, as Mike indicated, we had some updates on the redundancy. So there was a discrepancy that we found in the language between these 2 properties, min-num needed, min needed in group in redundancy. And there was a discrepancy between what was in the schema definition and what was in the mockups. So in the schema definition, the property stated that they were the minimum number of members needed to remain fault tolerant, but the mockups actually showed the minimum number of members required to be in the group. And so to resolve this discrepancy, the first thing we did was to survey existing implementations. And in most cases, people were following the intent that was shown in the mockups. So for showing a 1+1 redundancy situation, most implementations were having min-num needed and min needed in group as 1, which of course is not the number needed for fault tolerance. So we updated the descriptions for min-num needed and min needed in group to reflect what was shown in the mockups, and then created new properties, min-num needed for fault tolerance and min needed for fault tolerance, to specifically report those fault tolerance limits. Next slide. So, message registry updates, as Mike discussed. We have a new manager event registry with lots of messages that show state changes and alerts with your BMC. So an example of this is the manager reset message, which indicates that your BMC has gone through a reset. In environmental, we closed the gap, adding the fan warning message. We had others for fans, but we were missing fan warning. And then similarly, for cooling unit group, we added critical, warning, and normal messages so that you can indicate the status of a cooling unit group through register or through message events. The log service registry, we added a log cleared message so that you can properly track that in your audit processes. And then for power, similarly to environmental, for power distribution groups, we added critical, warning, and normal messages. So again, being able to reflect the status of power distribution groups um, through system events. So, as usual, our Redfish Publications repository contains the official read-only copy of Redfish schema and message registries. Um, and so this is very helpful because it creates a public durable location that can be used to reference the individual schema and registry items in things like issue reports or forum postings or any other online references. And it provides a synchronization point for developers to um, stay up to date with Redfish releases using the standard GitHub tools and processes. And as each release becomes public, each release of Redfish, that is, we update the registry so that you can always stay in sync. And the registry contains all of the material published in DSP 8010 and DSP 8011. So the subdirectories in it, there's CSDL, which is all of the Redfish schemas in the OData CSDL XML format. There's /JSON schema, which is the same schemas, only in JSON schema format. There's OpenAPI, which is the schemas in OpenAPI YAML format. There's dictionaries, which is the RDE dictionaries, which are used for PLDM for Redfish device enablement to enable Redfish in embedded devices. And then there's /registries, which is all of the standard message registries. We also have a number of conformance testing tools that are available. The Redfish Forum provides open source tools for service developers to validate their conformance with the Redfish protocol, data model, and profiles. So we've got the Redfish protocol validator, which lets you test a live service against the Redfish HTTP protocol. This will include all of the response headers and status codes. We've got the Redfish service validator, which lets you test a live service for conformance with the Redfish schemas, and lets you ensure that the returned payloads validate against the standard data models. In general, we recommend that if you're just getting started out, that this is the first tool you run, because errors in the payload are much more likely to cause issues for end users and for interoperability. The protocol validator is also important, but is less likely to cause issues. And then finally, we've got the Redfish interop validator, which lets you test a service against a Redfish interoperability profile to validate that it matches all of the requirements as set within that profile. And with that, let's go ahead and move on to the Q&A. So
if you have any questions, you can put them in the chat now. We'll answer them as they come in. We do have two questions that came in through registration. I can go through those first. The first question, I come from the automotive industry where fishbone and 8D methods are used for root cause analysis. Can you elaborate on them? So in the context of Redfish, Redfish is not directly tied into those types of methods, but when you're following the 8D process for identifying system problems, or you're building up a fishbone diagram to do your analysis of when faults can appear in a system and thus lead you to a root cause of how to mitigate those. Redfish could be used as a way to help normalize data across different implementations, different vendors. So if you have different failures from different sources, from different companies. Redfish would at least provide you a way to analyze data in a common format, and that could be used to help assist you in your root cause analysis. Uh,
So it's a tool for providing an input to the
yes,
fishbone diagram.
right. The other question, do individual PowerShell controllers require Redfish implementations? Um, so I guess first I'll try to clarify this. If by controller do you mean a like the logic block or the PLC that manages the lower order power functions in a PowerShell? Probably not. I don't see redfish living there. Typically, in a PowerShell, you would have some sort of SoC or microcontroller that serves as your interface to the outside world. So historically, it would provide a SNMP to go out of the box. It might also feature a web UI, so a user can bring up a web browser, log into the PowerShell, and manage the device that way. That's where Redfish would live on a PowerShell type of device. Once you go underneath that layer, it's up to you for what you use internally to manage the PowerShell. Uh, I don't see any more questions coming in from the chat.
So let's go ahead and do a final call for questions.
No, I think we're good.
Yep, looks like it. Okay, so we invite all of you to get involved in Redfish. So, as we've mentioned, the Redfish standards page has the schemas, all the specs, the mockups, a whole bunch of white papers, and more. Everything we've done about Redfish. A great way to get caught up and find out what's going on. Next, we've got our Redfish developer portal, which has our interactive resource explorer, as well as all of our educational material, documentation, and a whole bunch of links. We have our Redfish user forum, which is a great place to ask questions or to provide suggestions or just have a discussion about some aspect of Redfish. We very frequently take the questions and suggestions there and turn them into updates to the specifications or the schemas. It's a great way to uh, ask for a change. And then finally, we've got the DMTF Redfish uh, feedback portal, which is a way to formally provide feedback or submit proposals for Redfish standards. So the difference between this and the user forum is that the user forum is an informal uh, place where you can post as an individual user. The feedback portal is where you can post on behalf of an organization or on behalf of a company. And then finally, the DMTF Redfish Forum. Um, great to join the DMTF to be directly involved in updating the standards and the schemas and the message registries and all of the other parts that make up Redfish. And with that, thank you all for your attendance. This will end the portion of the webinar that is recorded.